Antarctica is melting faster than we ever feared, and the consequences could be catastrophic. This ancient ice holds nearly all of Earth's frozen water, and if it disappears, cities will drown, weather patterns will spiral into chaos, and long-dormant viruses could escape into the world. But that's not all. Deep beneath the ice, something far older than humanity may be awakening, something that was never meant to return. Tune in, as this could be the beginning of a global disaster. Antarctica is no small patch of ice. The landmass covers about 14 million square kilometers, making it 1.5 times the size of the United States. This vast expanse holds roughly 90% of the Earth's total ice volume and about 60% of the world's freshwater supply. It's like a giant freezer that not only keeps the planet's water cycle stable, but also acts as a mirror, reflecting sunlight back into space and regulating global temperatures. That reflective quality, known as the albedo effect, is critical. Without it, more sunlight would be absorbed by the Earth's surface, accelerating warming. But if the ice starts to crack, the effects could be catastrophic. The destruction wouldn't be confined to land. The oceans would undergo a massive upheaval as well. Antarctic meltwater is fresh, not salty, and introducing such vast amounts of fresh water into the oceans would disrupt currents that have flowed in relatively stable patterns for millennia. Currents like the Atlantic meridional overturning circulation help regulate the planet's climate by moving warm water from the tropics to the poles and bringing cooler water back down. Without these currents, weather patterns would shift dramatically. Europe, for instance, might face harsher winters, while equatorial regions would endure more intense heat waves and droughts. The global climate would become more unpredictable, more extreme, and more hostile to human life. Beneath the ice, things get even stranger. For millions of years, Antarctica's ice sheets have sealed off ancient ecosystems, burying microorganisms and pathogens that predate modern humanity. As the ice disappears, these ancient life forms could be reintroduced into the environment, carrying with them the potential for new diseases. Modern immune systems have never encountered these ancient pathogens, meaning humanity might face outbreaks we're ill-equipped to combat. This isn't science fiction. It's a real, albeit often overlooked, consequence of losing the ice. Beyond the immediate environmental consequences, the geopolitical fallout would be immense. Countries would fight to secure dwindling resources, and mass migrations would strain infrastructures and social systems. The balance of power would shift, with some nations gaining strategic advantages from new shipping lanes opened by melting ice, while others, particularly small island nations and coastal communities, would face existential threats. International relations would be tested as never before, with alliances forming and fracturing under the weight of unprecedented global challenges. The ripple effects would extend to culture and history as well. Iconic landmarks, from the Statue of Liberty to the Sydney Opera House, would be lost. Coastal archaeological sites would vanish, taking with them invaluable records of human history. The sense of loss wouldn't be confined to physical infrastructure. It would be an emotional and cultural wound that would linger for generations. It's not only the immediate deluge of water that would cause chaos. The chemical makeup of the oceans would shift, throwing marine ecosystems into disarray. Fish species that rely on specific temperature and salinity conditions would be forced to migrate, threatening the delicate food webs they support. Coral reefs, already under pressure from warming waters, would suffer further, with bleaching events becoming more frequent and severe. These ecosystems aren't just sources of food, they also play critical roles in carbon storage, nutrient cycling, and maintaining biodiversity. Their collapse would have cascading effects, making it harder to restore balance, even if temperatures eventually stabilize. The social and cultural consequences would be equally profound. Communities that have lived by the coast for generations would lose not only their homes, but also their sense of identity. The cultural traditions tied to specific landscapes, fishing practices, coastal festivals, historic landmarks, would disappear, leaving a void that can't be easily filled. Entire histories would be washed away, preserved only in memory and in archives far from the water's reach. And yet, amidst the destruction, there might be glimmers of opportunity. If humanity can marshal the political will, the Antarctic meltdown could serve as a catalyst for unprecedented levels of global cooperation. Countries might finally unite around shared goals like renewable energy, reforestation, and large-scale carbon removal. This moment of reckoning could push humanity to transcend petty rivalries and short-term thinking, ushering in a new era of innovation and sustainability. We would have to embrace radical change. Cities would need to be redesigned from the ground up, with a focus on sustainability and resilience. New agricultural practices would be developed to grow food in saline soils or using less water. Education systems would pivot to train the next generation of engineers, scientists, and policymakers to tackle these challenges head-on. The tragedy of losing Antarctica's ice might ultimately drive humanity to become more thoughtful stewards of the planet. However, these opportunities would not come without immense suffering. Billions of lives would be upended, economies would be destabilized, and ecosystems would teeter on the brink of collapse. The question remains whether humanity can act in time to mitigate these effects, or if we will simply react to them, always a step behind. The lesson of Antarctica's potential meltdown is clear. The choices we make today have consequences that will echo for centuries. A heat wave hit Antarctica. This could be just the beginning. This wasn't just a fluke one-day thing. Starting February 5th, the region felt like it was on a tropical vacation until February 13th. During that time, glaciers all over the place started turning into a slushy mess. The operational land imager on Landsat 8, basically an eagle-eyed satellite camera, caught this big melt happening on Eagle Island's ice cap. Over the course of a week, the place went from frosty white to soaked blue, with meltwater pooling all over. The imagery was telling us what the thermometers already knew. This was no normal day in the Antarctic neighborhood. Meteorologists pieced together what was going on, and it wasn't pretty. Turns out, a high-pressure ridge decided to park itself over Cape Horn, effectively giving the usual cold Antarctic winds a break. Normally, the strong west-to-east winds called westerlies block warm air from reaching the peninsula. But this time, those winds were chilling out, literally, allowing warmer-than-usual air to slip past and hang out over the ice. Add in sea temperatures that were running a few degrees above average, and you've got a recipe for a massive meltdown. But that's not all. Foehn winds, those gusty, mountain-sweeping, heat-bringing air currents, added fuel to the fire. These winds blow up over the peninsula's mountain ranges, dumping moisture as they rise. By the time they get to the other side, they're dry and warm, bringing an extra punch of heat. In February 2020, those foreign winds weren't just mild breezes. They were like nature's own hairdryer, blasting the ice and turning snow to slush. By the time this warm spell was done, Eagle Island alone had lost over 4 inches of snowpack, which was around a fifth of the usual seasonal snowfall. That's not a small drip in the bucket, it's a major hit. Meltwater covered nearly 1 square mile of the island's surface, making it look more like a water park than a snowy landscape. Glaciologists, the folks who study glaciers and ice, were pretty stunned. Maury Pelto, an expert from Nichols College, pointed out how rare it was to see melt ponds forming this quickly in Antarctica. Usually you get that kind of rapid melt in places like Alaska or Greenland, not down at the bottom of the world. The fact that it's now happening more often in Antarctica is kind of a big red flag. So what's the deal with this new normal? It all comes down to one simple truth. Antarctica's not the frozen fortress it used to be. The 21st century has brought more and more of these warm events, and February 2020 was just another brick in the melting wall. As we keep pumping out heat-trapping gases and the oceans warm, we're essentially giving these warm spells an open invitation to crash Antarctica's icy party. The numbers might look boring, but the message they carry isn't. A sustained heat event like this means the ice isn't just melting at the edges, it's melting on top too. Once that process starts, it's like pulling a thread on a sweater. The more you tug, the faster the fabric unravels. And if the Antarctic ice keeps unraveling at this pace, it's not just local glaciers that are in trouble. It's global sea levels, ocean currents, and the delicate balance of our planet's climate system. Bottom line, what happened in February 2020 wasn't just a fluke. It's a flashing neon sign that the ice is losing its chill, and the planet might be losing its cool. Another aspect to consider is the shifting behavior of atmospheric circulation patterns. Normally, the southern hemisphere's westerly winds help keep the Antarctic peninsula cooler by blocking warm air masses from moving in. But when these winds weaken or shift, as they have more frequently in recent years, warm air is able to break through and reach the ice. This kind of pattern was evident in February 2020, when the westerlies took a back seat and allowed that high-pressure ridge over Cape Horn to set up shop. The result? A prolonged, intense heat wave that melted snow and ice at unprecedented rates. Even though these warm spells might seem short-lived, just a few days or weeks, their impact is far-reaching. Melting snow and ice contribute directly to rising sea levels. While the Antarctic Peninsula doesn't have as much ice as East Antarctica, for instance, every bit of meltwater adds to the global tally. And as more of these events occur, the cumulative effect becomes harder to ignore. Scientists are now seeing signs that parts of Antarctica, once thought to be relatively stable, are starting to show signs of significant long-term change. This brings us back to Eagle Island, where that February 2020 heatwave turned the ice cap into a pool party. Satellite images showed melt ponds forming across large sections of the island, something that would have been almost unthinkable just a few decades ago. The rapid pace at which these ponds developed stunned researchers like Maury Pelto, who commented that this kind of quick melt is something you'd expect in Greenland or Alaska, not Antarctica. This shift highlights how dramatically the climate is altering what's normal for this frozen continent. Looking ahead, the big question is, what can be done? Addressing climate change isn't just about reducing emissions anymore. It's about understanding how these shifts are reshaping our world and figuring out how to adapt. For the Antarctic Peninsula, that might mean closer monitoring of melt events, improved climate models to predict future changes, and increased international cooperation to curb global warming. The stakes are high, not just for the ice, but for the millions of people worldwide who live in coastal areas that could be affected by rising sea levels. Thwaites Glacier is melting. Its collapse would change everything. To put that in perspective, imagine an ice mass equivalent to tens of millions of Olympic-sized swimming pools disappearing in a few short years. Such a rapid rate of ice loss was unexpected, and it has prompted scientists to revisit their assumptions about how glaciers behave. For a long time, researchers suspected that warm ocean water was sneaking in under the ice, melting it from below and creating small voids. But the magnitude of this cavity far exceeds those initial guesses. It's not just a tiny crevice, it's a gaping hole that hints at processes happening far more quickly and forcefully than previously thought. This discovery was made possible by combining data from multiple sources. NASA's Operation Icebridge, an airborne mission that started back in 2010, uses sophisticated radar instruments to penetrate the ice and map the contours of the glacier's underside. Complementing these efforts, Italian and German satellites equipped with synthetic aperture radar provided high-resolution imagery that allowed scientists to measure subtle shifts in the glacier's surface and detect how the ground beneath it was moving. These cutting-edge techniques gave researchers a clearer picture of what lies beneath the ice, revealing details that traditional methods could never uncover. One of the lead scientists involved in this research is Eric Rignot, who has spent years studying Antarctic glaciers. According to Rignot, the data confirms what many glaciologists had long suspected. Thwaites Glacier is not securely anchored to the bedrock below. This lack of attachment means that warm ocean water can easily reach the glacier's base, melting it from underneath and accelerating the retreat of the ice sheet. The new generation of satellite technology has made it possible to observe these changes with unprecedented precision, turning theories into measurable facts. What makes the situation even more alarming is that Thwaites Glacier serves as a crucial barrier for neighboring ice sheets. Think of it as a giant stopper that holds back other glaciers, preventing them from sliding into the sea. If Thwaites were to collapse entirely, it would remove this barrier, unleashing a cascade of ice from nearby glaciers. The resulting rise in global sea levels could be catastrophic. Currently, Thwaites alone holds enough ice to raise sea levels by about 2 feet. If the neighboring glaciers it supports also begin to collapse, the additional ice loss could push sea levels up by another 8 feet. To understand the complexity of this process, it's important to grasp how scientists measure and monitor ice loss in such a remote and hostile environment. Setting up instruments on the ground is virtually impossible due to the harsh conditions and the vast scale of Antarctica's ice sheets. Instead, researchers rely on satellite and airborne data to track changes in key features. One such feature is the grounding line, the point where the glacier's underside lifts off the bedrock and starts to float on the ocean. As the glacier loses ice, this line retreats further inland, exposing more of the glacier's base to warm seawater. This in turn increases the rate of melting, creating a feedback loop that drives further ice loss. The cavity beneath Thwaites Glacier isn't the only troubling sign. Scientists have observed other indications of rapid change, including thinning ice and accelerated flow rates. These changes suggest that the glacier is losing its grip on the land beneath it, making it increasingly vulnerable to collapse. The entire system is in a delicate balance, and even small changes can have significant consequences. For example, as the grounding line retreats, the glacier becomes more unstable. The ice that was once firmly attached to the bedrock now floats more freely, making it easier for warm water to reach further inland and melt the glacier from below. Researchers have also noticed that the rate of melting varies across different parts of the glacier. On one side, the grounding line has been retreating steadily for decades. On the other side, narrow channels in the bedrock allow ocean water to seep in, melting the ice at different rates. These regional differences highlight the complexity of the ice-ocean interaction and underscore the need for detailed, localized studies. Scientists like Pietro Melillo, another lead researcher on this project, have been using advanced radar techniques to track these patterns. By analyzing high-resolution data, they can see exactly where and how the ice is melting, providing critical insights into the processes driving this rapid change. The consequences of Thwaites Glacier's instability extend far beyond Antarctica. Rising sea levels threaten coastal communities around the world, putting millions of people at risk of flooding and displacement. Cities like Miami, New York, and Jakarta could face severe challenges as water levels rise. Low-lying islands in the Pacific and Indian Oceans may become uninhabitable, forcing entire populations to relocate. The economic and social costs of these changes could be staggering, affecting everything from infrastructure and agriculture to public health and international relations. To address these challenges, researchers from around the world have joined forces in a major international effort to study Thwaites Glacier and its surrounding environment. The International Thwaites Glacier Collaboration, supported by the US National Science Foundation and the British National Environmental Research Council, is conducting a multi-year field project to answer critical questions about the glacier's behavior. By deploying advanced instruments and conducting on-site measurements, scientists hope to gain a deeper understanding of the processes at work. This research is crucial for developing more accurate models of sea level rise and informing global efforts to mitigate the impacts of climate change. The findings from Thwaites Glacier have implications for climate science as a whole. They reveal the importance of studying the undersides of glaciers, where much of the melting takes place. Traditional ice sheet models often underestimate the rate of ice loss because they don't account for the dynamic nature of these cavities. By incorporating more detailed observations and improving the accuracy of these models, scientists can make better predictions about future sea level rise. This in turn can help policymakers and planners prepare for the changes ahead. This level of detail and complexity underscores the need for continued investment in polar research. By understanding the intricate processes driving ice loss, we can make more informed decisions about how to respond to this unprecedented challenge. Thwaites Glacier is not just an isolated piece of ice in a far-off land. It is a key indicator of the planet's health. The insights gained from studying this glacier will shape our approach to climate change for years to come. As we learn more, it becomes increasingly clear that we must act swiftly and decisively to address the impacts of a warming world. If Antarctica's ice continues to melt at this pace, can we still prevent irreversible consequences, or are we already too late? Leave your thoughts in the comments, like and subscribe for more.